Now, let us understand how a conventional neural network or CNN understands an image and makes a decision. In this animation, you will see every internal step that normally happens invisible inside a computer. We will see the same network working on two different images to prove that the process remains the same, only the data changes. So the assessment starts with input image. On the left side, we starts with the input image highlighting inside a yellow box. This could be a cat image or a robot character. Although we see a picture, the computer does not see objects. It sees this image as a grid of pixel values called raw pixel data. Moving ahead, step 1, forward and first conventional layer. Now the image enters the first conventional layer. You can see a small sliding window moving across the image. This window is called a filter or kernel. As the filter slides, the network starts detecting basic features like edges of the image, lines of the image, and simple curves of the image. On the screen, this is shown a blue stacked rectangles, also called feature maps. The chord flip animation indicates that multiple feature maps are being generated at the same time. Moving ahead, step 2, first pooling layer. Next, the output goes into the first pooling layer. Pooling helps in reducing the size of the data while keeping only the most important information. You can see the feature maps becoming smaller green stacks. These steps make the network faster, efficient, and less sensitive to small changes in the image. Moving ahead, step 3, the second conventional layer. Now the compressed data enters the second conventional layer. Here, the network combines earlier features to learn a more complex patterns. What were once simple edges are now combined into shapes like circles, corners, or texture. This is shown using yellow stacked feature maps, again with a flip animation. Moving ahead, step 4, second pooling layer. Once again, the network performs pooling. The feature maps turn orange and become even smaller. This step ensures that only the strongest and most useful patterns move forward to the next layer. With third conventional layer, which is step 5, explains about. Now comes the third conventional layer. At this stage, the network starts recognizing high level features. These features are object specific, such as parts of an eyes, parts of an ear, wheel, or antenna. So there are certain features it is trying to identify individually. This learning is shown using purple feature maps. Moving ahead, step 6, which is third pooling layer. Finally, we apply one last pooling operation. This feature maps turns pink and become very compact. At this point, the network has extracted all important information from the image. Moving ahead, the step 7, flatten layer. Now the conventional neural network transitions from feature extractions to decision making. All the two-dimensional feature maps are flattened into a single one-dimensional vector. You can see this as a vertical column of small gray rectangles. This step prepares the data for fully connected neural networks. And in step 8, the first hidden layer will come into the picture. The flattened data is now sent to the first hidden layer. You can see 5 blue neurons, each connected to all input values. The glowing lines show how information flows and weights get activated. Each neuron learns to recognize different combinations of features. And in the step 9, second hidden layer will come into the picture. Next, the data moves into the second hidden layer, which has 3 neurons. This layer refines and combines the learned patterns. The network is now performing a clear understanding of what the image represents. And in the step 10 output layer, which is the final decision making, finally we reach the output layer. Each circle here represents a possible class along with the probability value. For example, cat 0.85, which is 85% confidence, the image can be a cat, and dog, which is 0.10, which is 10%, it can be a dog, and 0.05 a percentage, which can be a bird. The brightest circle shows the highest confidence, which becomes the final prediction. And when if we see the bottom labels explanation, at the bottom we can see two brackets. The left bracket represents feature maps, feature extraction. The right bracket represents fully connected layer and a classification. This clearly shows that a convolutional neural network works in two main phases. The first one is feature extraction and the second one is classification. So from this example 1, cat classification, in the first example, the input image is a cat. Because of 85% of the confidence, it is explaining that it is a cat, and 10% it is a dog, and 5% it is a bird. Therefore, out of these three, the input image, it can be a higher probability of 85% it is a cat. Since the cat has the highest probability, the network correctly classifies the image as a cat. Moving ahead, the second example, robot classification. In the second example, the input is a robot character. The output probabilities are robot, which is 92%, alien, which is 5%, monster, which is 3%. Again, the network selects the class with the highest confidence, which is a robot. With this visual understanding, conventional neural networks are no longer a black box. They become clear, logical, and intuitive for image classification.